try to get through this as quick as I can because today's assignment is better if you do it on the graphic calculator than doing it on Desmos. Half of these things. My plan is to give you a quiz over this tomorrow to see if you got it. Okay, and I know I think this probably we might do that today too. Okay, so only 5 minutes. It's not a huge thing. It cuts you off at 5 minutes. Okay, it really should take you. So it's a very, very quick thing. All right, ready? Okay, so I put a lot of notes in that left-hand column for you today. I was doing this. I couldn't sleep at about 1:45 this morning, so I got up because I knew at some point the baby would wake up and I had to take care of him. So I might as well get up and work. So I don't know if I got mine. I didn't have one of the calculators at home, so hopefully I got all these blanks right. We'll see. Okay, I was trying to do this from memory of the calculator. So plug the equation into F1. Okay. Anytime the calculator's questions are very short. I believe on the multiple choice it's like 10 to 15 questions somewhere in there, and on the free response it's only 2 calculator questions. You don't have a lot. Okay. Every time you have an equation, put it into F1. Don't try putting it on the calculator page because F1 then you can manipulate the function on it. Right? Okay. Then you go back to the calculator page and you want to push Shift and plus. Okay, and that's your integral. Shift minus is the derivative. Okay, we just need the derivative. Okay, it's a nice shortcut. I can't take credit for it. About 4 or 5 years ago, one of the students found it. Okay. All right. So it's you guys. All right. So you're going to type the upper and lower bound. And you can only do this on definite. You can't do this on indefinite. Okay, because you have to have an upper and lower bound to do a calculation. Okay. Push bar, and then choose F1, and then type an X in the parentheses and after the D. That will make sense when you see it. Okay. You may or may not. Some of you have probably seen this before. I know you last Saturday. Okay. A little bit. Okay. He was really fast. All right. I'm going to redo his lesson probably tomorrow. Okay, so we're going to use the calculator to find the definite integrals. I literally don't need to write anything but the answer. Okay? And there are a few questions on the AP test, even on the free response, that are like this, where you just literally write down the function and the answer. Okay? So we're going to go right into the calculator. I'm going to be clear what's there, doc B. Okay. All right, now, there's something wrong with my calculator right now. Does anybody see it? I'm in degrees, so we need to go and check that. We are getting into that time of the year where Algebra 2 Trig is starting to use the calculators, and in about 2 weeks, they're going to be in Trig and put it in degree mode. So that's the first thing you need to check when you look at your calculator, okay? For calculus, it's only radian mode. Okay, so doc settings, I need to flip it back to radians. Radians is just it's another degree measurement, and I know that there's some scientific something that uses it. Alright, so I'm going to go back here now and I scratch pad and it's in the right book. Especially because I saw my first problem was Trig, right? I don't know why I put it. Okay, let's put our function next. So our function was, what was our function? Sine, right? I don't know why I got to put a square in there. Okay. Alright, so we're going to type in the sine. So sine, so we go to the little trig and hit sine, x. Again. And again, I'm putting that there because when I'm getting in that habit, when I do a free response problem, I'm going to have to do more than one thing with that function. So it's better to just put it in that. Okay? There's a picture of it. Wait till you see some of the pictures I came up with today. All right. Because at 3 o'clock or 2 o'clock in the morning, I came up with all these things. All right. So I said you're supposed to hit shift. Shift is above the 7. So shift plus. Our nice little integral symbol. Okay. If you don't remember that, hit this button, see the book button? Next to the book, there's a whole bunch of stuff in there. There's derivative and integral in there as well, okay? And all the fraction stuff, all the everything else is in there if you ever miss it. Or you can always hit that book button and everything is technically in there as well. Okay, you just have to hunt for it. Okay, so I don't like hunting, I like memorizing the keystrokes, especially as a time saver. Okay? All right, 1 We're going to go up to above the 9 and hit the lower button. F1, and this is where you type X in the parentheses and X after the D. Because you have to tell the calculator what your variable of integration is. Okay? And then hit enter. How many decimal places? 3, so 1.193. Chop it off, right? Do not round. Okay? Stop rounding. As you notice. Yeah. And then we write the 1.193. Okay. Okay. Alright, ready? Okay, so the next one says that we got, and I tried to, I was really trying to pick crazy functions. This one isn't even that bad. But trying to get you to practice putting in something that's really complicated with a calculator. You have to be able to do that without help. Okay? I know, wait, you see some difficult questions. Alright. So, we're going to go back in here to this. If you want to, it's easy. It's quickest to hit a dot B. Okay, rather than trying to delete everything out. So I'm going to hit dot B to get rid of it. And then we're going to go, I'm going into the F1. So E, remember, is next in row 1. So E, to the negative 3x. And then make sure you're not in the exponent anymore. Plus, and then we need natural log, which I believe is above the E. Natural log of x. And then make sure, and that's it. Right? Hit it. I did expect something different. That was not this one. There's some good ones though. Alright, then I'm going to go back to the calculator page. What do I push? Shift plus. Good. And we're going from 2 to 12. Those of you that have gone to Saturday, he's using the 84s, which I like this calculator better. And like how he was talking about slow or speeding the screen up, we don't have to do that for ours is fast. Alright. Alright, F and R, F of X, or F1 of X, yeah, hit enter. And then write down that. So 18.433. Okay. So 18.433. Okay, ready for the next part? Yeah. Okay, so out of the left-hand column again, so we're going to change how we're doing the example slightly. Okay? If it is impossible to take an integral, then you must use the fundamental theorem of calculus. And your calculator. So a huge clue is if you are in the calculator portion of the test and they give you a function, you put it in your calculator. Okay? You do not try to integrate by hand ever in the calculator section. Okay? They're trying to test that you understand how to use the calculator. Okay? Alright. So let's look at the next piece. So this is the only one, these two problems have a little bit of work we actually have to write down. Okay, of course the other one's just pretty much typing it in. So if f is the function defined by e to the cosine x, and g is the antiderivative such that g of 1 equals 4, then they want us to find g of 0. Okay, so what we know is that g is the integral of f, right? Because I said it was its antiderivative. So I need to integrate f. So I'm integrating my f function, but I have a definite integral going on. And this is a little bit crazy. You've got to understand this piece. The definite integral, okay, goes from it always starts at 0, and then it goes into whatever x value that is. So that it goes to 1. Okay. And I'm going to go ahead and I'm going to apply that integration. Okay. So it said when I integrate f, what do I get back to? G. So I've got g of x from 0 to 1. So I'm following first fundamental theorem. That says I got to plug in g of 1 minus g of 0. Okay? But I know a little bit more. Okay? Oh, they gave me a function. Do I know, could I put this into my calculator? going to go into my scratch pad and I'm going to type in, it was e to the cosine x. So it's e, the cosine, so we're putting a trig function inside of it. Okay. Oh, there you go, that looks good. Doesn't look like there's a cosine or cosine function. Alright. Second rule, let me use that in the broad waves. Alright, I can see like Lilo and Stitch. Okay, so I'm going to go back here to this, and I'm going to hit Shift what? Shift plus, good. And I'm going to go from 0 to 1, and what do I hit? R, F1 of X, and then Z, X. Yep, now, when we're talking about this, you do not write down 3 decimal places until the very end, because your answer needs to be 3 decimal places accurate. That means when you're calculating, you really need more decimal places. Look at how many more my calculator is able to give me because I copied and pasted. Okay. What is G of 1? Do I know that? They told us it's 4. So I've got this 2.341574. Usually about 6 is good. Okay. 4 minus G of 0. That's why in our calculators we have our float set to like 6 or 8, because you need to be accurate to 3, not just rounded to 3 in the middle. Okay? Yeah, a couple of weeks ago, Ellie was doing something with decimal points, and she was chopping stuff off. She was doing like area circle or something, chopping stuff off in the middle of the problem, and I was just cringing because of the answer that didn't do it. All right, so gotta be fun to be the kid of the math teacher, right? All right, so we gotta feel sorry for our poor children. All right, so although they have a lot of help at home. All right, so we gotta subtract that 4 to the other side. I'm gonna use my calculator to do that for me, so I know that I'm accurate because I'm tired. So I'm gonna subtract, and look at all I have to do. See how I just typed the subtracted and automatically is gonna use that answer from before. Okay, equals, and then did you notice the sign? Is it even gonna flip the sign on us? So it should really be positive of that. Go back. Alright. Because I got a negative in front of the G of 0. Okay, so coming out of the calculator it was negative of that, right? I gotta divide that over. So now I can go to 3 decimal places. So 1.658. Okay. Okay. Looking at this one. So similar problem. Okay. The function looks a little bit ugly. Alright. So we're gonna go ahead and I know that they told me that G of X equals this a similar question. They told me that G of X equals this integral. They gave me that G of 5 equals 4 and G of 6 equals 6. Okay. So I'm going to really integrate from where to, I want to integrate starting here and going to there. So I'm going to start at 5, and I'm going to go to 6 of this wonderful looking function. Yeah. Okay. All right. I'm going to literally just plug it in the calculator the way it looks, other than I'm going to put this into F1, right, just in case later on I have to use it. All right, so let's try this. Copy everything. Okay. We will, as we get closer to the test, show you how to set up documents in here. Because when you set up documents in there, then when you're working on a calculator, like you say you want to do free response 1, and then you want to go to free response 2, then you want to do the calculator. Right? And that way you can go back. I'll show you how to do that. Okay. Control divide. And we've got 5x. Okay. And then 3x plus, and this is one I haven't taught you how to do derivatives or integrals on the exponentials of the so compare 2x. You don't really see it that often. All right, and enter. Okay, let's look here. says 5, and then hit enter. It's hiding underneath where it says lower bound right now. And then hit 6, and hit enter. And you see here how I got the exact same number right there? I'll do it again. Menu, analyze graph, integral. This is another way to do the same thing. It says lower bound question mark. I never try to use that. I just type in the number that I want so I'm accurate. So see how 5 popped up? Enter. And then I type it. I don't know why it says lower bound again. It should say upper bound, but 6. Enter. And then that, see how it even highlighted the area? You can actually see the shading of where the area of the curve is. Okay. So that's another way to do it. All right. Let's look at the back side. Let's take a look at the 19th grade. All right. So, we got to find the derivative at a value using your calculator. So we're going to use the derivative to find it. We're just going to review this real quick. I think we've done it before, but I can't remember. I thought today was a good day to bring it back to us. So we're going to plug the equation into F1. Go back to the calculator page. Push menu. Choose numerical. Let's see if I'm right about this. Derivative. That's just numerical. Derivative at a point. Type whatever number you want for x, whatever number you're supposed to be evaluating for. Push. Oh. And then type in x. It's got to be there. Oh, so it's push bar F1. The same thing as we did on the lead. All right, do I need some records? All right, I'll get up to you. All right, copy. Get rid of it. Okay, so we're going to do shift. No, I'm not going to do shift. I'm typing my function up there, right? Oh yeah, I got to do a control flag, right? 4x. And then 3 e to the x. And my goal today was to make it crazy because you're going to have to be able to put something crazy in x squared. That's x squared. And then, I need to do show you again what I do it. Okay, let's go back to the calculator page. All right, we're going to hit menu. Oh, I missed the thing. It should be menu calculus.
Yeah.
Okay, so we got to add that into our instructions. So menu calculus, we'll go back and do that in a second. Numerical derivative at a point. For value, that's where we're going to type in 71 and 3, right? Type in a 3. You can either do first or go straight to second derivative. So if we only want first, so we're just going to go first. Okay? And click OK, and then this is where you got to go bar F1 of x. I don't think that x has to be x. Can you do it again?
Yes.
Yeah.
Okay. I went really fast, sorry. Okay. Menu. Calculus. Numerical derivative at a point. For the value, you type in whatever the number is you're supposed to be evaluating at, so 3. Okay, and then this is where you go bar F1 of x. We need to edit our little thing on the side right now. Are you in the calculator page or in the graph page? You need to be in the calculator page. Different things pop up when you're in the different spots. Okay. All right. So let's go back here and let's actually. So it should be. We need to put in like 1.5, right? Oh, should we? 2.5. Menu. No. 3.5. Calculus. Okay. I know, it's bad. first three. You have to be accurate to your first three. The other thing you have to do is you actually do need to do this label on it. If you just write the number, it's called a bald answer. They don't give you credit for it. Right? Okay? You have to tell the grader that you understood that that was the derivative evaluated at 2, or negative 2. Okay? Alright. Let's look at this one. So this is different. We're now going to use our, oh, I missed the stuff on the left side. I didn't get in there. Okay, so let's go. I'm going to spin a number real quick. Okay, so plug the, it's supposed to say left side into F1. Okay. Plug the right side into F2. Push, let's see if I can remember what I was going to do. Push, I think it is supposed to be menu. And then 4 is analyze graph. Push analyze graph. And 5 is push intersection. Okay, drag the line to the left. And then the 7th one is drag the line to the right. And push, oh, and push enter. Not for each one of those. Okay? See if I did it right. Good news is I don't really need a lot of writing. So basically, here's what happens. You get a crazy looking function. There's no way we would be able to solve that by hand, right? So it's using systems of equations is basically what you're doing to backwards solve it. And this happens a lot on the AP test. Okay, it's a really good way of, if you know how to do this, it's a nice way of being able to solve it and not get stuck up. All else fails, left side goes into F1, right side goes into F2, and find the point of intersection. Okay? Alright, it's a really slick way of solving the problem. Okay, so dot B. Okay, so I'm going to put the left side in. So I've got 5, again, I grabbed crazy things. 5x square root. That's not the square root. Alright, I can't see them anymore, so. Alright, e to the x. And then minus x. And just that left side. You don't put in the 3 yet. Alright, so there's my function. Alright, and then I'm going to go hit the tab key, and I'm going to put in F2, I'm just going to put in the 3. It's going to give me a horizontal line. Okay? So this one didn't give me any domains, so we're going to find those. So see how it intersects twice? So how many answers are there? 2. So we go menu, analyze graph. What did I say we were supposed to push? Intersection. This is not something new. We did this last year. Oh, I don't really agree. Alright, so I'm going to go to the left of it, I'm going to go to the right of it, there's my first point. The answer, notice, the 3 was what we typed in, wasn't it? The answer is just this x. Alright, we'll do it again. Menu, analyze graph, intersection, go to the left, go to the right, there's my answer. I'm just going to grab my 2 answers. Okay. Alright, so get your 2 answers written down. And I'm going to show you how you would write that on the AP test. Okay? So on the AP test, remember, I can't leave it like that. It's a bald answer, right? Well, they didn't give me, what we were solving for was x. I have to say x equals, you can't put a comma in between, and that's okay, but don't put parentheses around it, right? Now you turn it into a point or an interval. Right, you say comma in between. And again, if I wrote that many decimals, I'm still good, right? As long as I'm accurate. Okay? Alright, let's try another one. So, left side, right side. Okay, but look, there's a domain issue, isn't there? So I know I'm only answering this between 0 and 1. Okay, so let's try it. So I'm going to dot B, get rid of all my hard work. Dot B. Alright, so I am typing in. I'm going to start with a control divide for retraction. And natural log of x. So control E is the natural log of x. You get it? Is it great looking? Alright, trig cosine. I was into cosines. means that you're gonna isolate where your answer is. Okay? I'm gonna click OK. Alright. Now what did it say? I now have to type in -2, right? So I have to go to tab, and -2 is gonna go into my F2. There we go. Menu, Windows Zoom, Windows Settings. So when I want to isolate a domain that's stated, I use Windows Settings. If I'm looking for my graph and I'm hunting for it, I use like a Zoom domain. Alright, and then I'm going to do, what am I going to hit now to get that point of intersection? Menu, Analyze Graph, intersection. I'm going to go to the left, I'm going to go to the right. There, and what value do I want? Do I want the X or the Y? Only the X, right? Not the Y. Remember, we're using our calculator to solve for X. We're just kind of tricking it and we're using the systems of equations to do that solving. Can I just leave that number? I believe when I did my answer, because it's a Power School assignment, it's just the number. So today you're just going to type in the number, but when you write it down, you should really be X and X. Okay? Alright, we got one more exciting function to do. You're not doing it? What's wrong with it? Oh, it looks a little weird. Okay, so first thing first, hit .b. That's going to get you, the nice thing about .b is it's going to get you back to your standard window. See how it took us back to a 10 by 10 and it's -7 to 7? Okay, so that way you actually might be able to see whatever the graph is or adjust it from there. Alright, it's 2 to the x. So 2 to the x. Alright, and then make sure you get it out of the exponent. Then we've got to do a square root, so control x squared. Natural log, I'm just trying to see how many different functions I get out of it. Natural log of sine of x, but watch where your squared is. The squared needs to go outside the sine parentheses, which is the second set of parentheses. Okay? And then I gotta go -2. Is it crazy looking? The -2 goes under the radical according to the equation. Okay? Is it crazy looking? Oh, it's weird looking. It'll look better, doesn't it? Nope, that's it. That's what it's supposed to look like. Alright, now.
What?
Alright. It says we've got to go from 0 to 2, so let's look at 0 to 2. Maybe I don't know, maybe we'll see what happens. So I'm gonna go to Windows Zoom, Windows Settings, and I'm gonna adjust it for 0 to 2. Click OK. Oh, look at curves there. Look, little curve that came up. I don't know if we're gonna get a value. We'll see. Okay? We can get a value when we did the intersection. Oh, so we gotta do we gotta put in a 0, right? So f equals 0. F2 equals 0. We need to find where those intersect. What do I push? Menu. Analyze graph. Intersection. I'm going to go to left. Go to right. Oh, I got a number. Now, what I actually just calculated there was a 0, wasn't it? So there's a second way to do that. We could have also done menu, analyze graph, and 0, and just grab that graph, go from left to right. See how I get the same thing? Okay. Those of you that went on Saturday, the guy on Saturday, he always puts it into Y2 for his zeros. I think this is a kind of intersection. You only have to remember how to do one thing. Okay, so I thought that was kind of an interesting little trick. Okay. I only want the X value. Look at the Y value. Wasn't it supposed to be 0? It's really close to 0, right? It did not quite exactly 0. Alright. That's it. Okay? I'm not going to do the little quiz you guys are supposed to do. Okay. We will do a little quiz over this tomorrow. Okay? Alright? You guys do need to find some time. If you've got a few minutes, you might want to get into Power School. Try a few of the Power School problems. Okay? Because I'm not going to let you go till 45.